right, so whenever you do a division, there's a dividend, a divisor, and a quotient. Right? When you carry through the division process, you could end up with a remainder. The way we handle that remainder is by adding it on to whatever the, I'll call it the even quotient is. All right, so whatever divided, a number of times it divided evenly into the dividend, the divisor did, that would be the first number. And whatever's left over would be as a proportion of whatever the divisor is. All right. So that's how we're going to structure our answer when it comes to polynomial division, which is to say that we're going to get a quotient that could have a remainder. So whatever that remainder is going to get tacked on as a fraction at the end of whatever the expression is. All right. We're looking at any division problem that's in the form of some sort of function, p of x, divided by some potential, I'll call it a potential factor, x minus r. All right. So the way we handle it, and this is all listed in the procedure, but you can look at that and be like, okay, that's really helpful or not at all. I don't know. But I think in the process that I'm about to show you, it'll all become clear. All right. So what we do is we list all the powers. And as you go forward with this, you won't necessarily have to list all the powers. It's just really just to give you an idea of placeholders. So I'm starting off with a power of 2. So what I need to have, if I were to rewrite this as 1x to the second minus 5x to the first minus 12x to the 0th, I need to have every power accounted for, starting with that highest power all the way down to 0. All right, so if you want, you can list the powers as 2, 1, and 0. All right, we're just looking at that as a set of placeholders because what we really need is a set of coefficients. Those coefficients associated with the term that has the power. So a coefficient of 1, -5, and -12. So what I'm going to do is I'm going to create a little synthetic division bracket. I don't know if there's actually a nice name for it, but I'm going to do the division bar for synthetic division. Using the R value, I'm going to carry through that process and come up with the quotient. All right. Now, if I tell you that your divisor is going to have the form of x minus r, that tells me that x minus r has to be equal to x minus 3 in this case, which means r has to be equal to 3. R is what goes on the outside. All right, so that's always going to be whatever r is. All right, for a lot of people, it's like, all right, I have the factor, just flip the sign of the factor. That's usually good enough. For now, we're only worried about procedure. We're not really getting into why this works. I'll explain all the whys down the line. But for now, it's just the how. All right. So there's some stuff that I'm about to do. If you've never seen synthetic division before, you're gonna be like, how do you know to do that? Right now, it's because I'm telling you, but later on, I'll justify. All right. So the first thing we do is we carry down the 1. All right. So right off the bat, something that doesn't feel like we should be able to do. All right. But really, it's a placeholder of 0. 1 plus 0 is 1. But we just carry it down for simplicity. We take that 1, we multiply it by whatever the r value is, and put the result underneath the next coefficient. All right, so 1 times 3 is 3. Add down the column. -5 plus 3 is -2. Take that result, multiply it by whatever that r value is. That goes under the next coefficient, so -6. Add down the line, and you get -18. All right. So we have the coefficients of our quotient. We just need to know what that translates to in an actual quotient. All right. The last term will always be the remainder. The first coefficient will have a variable raised to a power that is 1 less than what you started with. All right, so we started off with a power of 2. This term is going to start off with a power of 1. And we're going to use up our coefficients, aside from the remainder, until we get down to a power of 0. If I'm decreasing consecutively from 1, the next value would be a 0. All right. So if I started off with x to the 7th, if my original problem was x to the 7th divided by something, then my answer would start off with an x to the 6th. Always one power less than what you started with. All right, so this simplifies down to just an x minus 2. All right. The remainder, we put our remainder over the divisor. If you want, you could write this as minus positive 18 over x minus 3. Either way is fine, but this would be my quotient. All right. So this whole thing is my quotient. All right, that x minus 3 is our divisor. We get that from the thing that we're dividing by. All right. Little note.
Lockdown status has been.
All right, so my quotient is x minus 2 plus negative 18 over x minus 3. The little notation that I would throw in here is that if you get a remainder other than 0, so if you get any kind of remainder, it means that what you had as your divisor is not a factor of that original expression. So if the remainder, I'll just say, is not equal to 0. All right, so if you get a remainder, then the divisor is not a factor of the dividend. All right, there's terminology here, but in ordinary speak, I guess it means that x minus 3 is not a factor of x squared minus 5x minus 12. All right. So it's not a factor. Now, it didn't ask us for that, so we technically wouldn't have to write that, but there will be questions that ask you, is one expression a factor of another? And that's how you would address it. You'd run through the synthetic division process. If you get a remainder that's not equal to 0, so you get anything other than 0, it means it's not a factor. All right. If you get a 2 equals 0, it means it is a factor. And if you look at this I would say for this particular example, and think, well, that's kind of pointless because I could just factor what I started with and see if I get x minus 3. I agree. It kind of is pointless for a quadratic because we know how to factor quadratics. All right. So, yeah, let's get those laptops away. So an extension on this is something called the remainder theorem. This will also feel somewhat pointless, at least early on, but we're kind of in the phase of the course where you just sort of have to believe that this is going somewhere. It's like in the beginning of a movie, it's like, do I care about this? And then later on, oh, plot twist, it mattered all along. Right? So that's what's going to happen here. So the remainder theorem is saying that if you wanted to find f of r, and you run through the synthetic division process, whatever the remainder is will be the result of f of r. So I'll write an example here because I forgot to include one. If f of x is equal, let's say, 3x to the 9th plus x to the 4th minus x plus 2. It doesn't matter. If I ask you to find f of 1, one thing that you could do, if this were back in Unit 1, is you could pop in that function that I just gave you in its full-blown hideousness. Oops. It's actually not terrible, but I could look at the graph and figure out what the y value is when x is equal to 1, so 5, easy enough. I can go into the table and see at 1 the y value is equal to 5, that's fine too. All right, no problem there. But what we're going to have to do is find the remainder using the remainder theorem. All right, so on a test, it's going to say using the remainder theorem. If you go to the calculator and you get your answer of f of 1 equals 5 and write that down, you won't get any credit. All right, so you have to use the approach that I'm about to show you. So whether you want to list the powers or not, that's up to you. I'm going to do it. People have said it's helpful, so just at least in terms of structure. I'm starting off with a power of 9. I need to go 9 all the way down to 0. So 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. All right, the coefficients. The coefficients are 3. I don't have anything for 8. Right? I don't have anything for 7, 6, 5. I do have for 4 is a 1. 3, 2 I don't have there. I got a -1 and a 2. So I would fill in everything that hasn't been accounted for yet with a 0. All right, so 3, 0, 0, 0, 0, 1, 0, 0, -1, 2. All right, because if I really wanted to, if I wanted to write this in appropriate polynomial form, which accounts for every exponent, instead of what I have as f of x, it would really be 3x to the 9th plus 0x to the 8th plus 0x to the 7th, 0x to the 6th, 5th, 1x to the 4th, 0x to the 3rd, 0x to the 2nd, minus 1x plus 2, which would be a whole lot more writing than you would probably want to do. All right. So I would then apply my synthetic division, but this time the number on the outside is going to be whatever you plan on evaluating the function in terms of. All right. So that's my R value. Whatever you put on the outside needs to be, well, it needs to be R. So whatever you're given, you need to figure out what R is based off of that given. All right. In this case, if I'm telling you that f of R is the remainder, then whatever you're plugging into the function is my R value. All right. So I pull down the 3, multiply, 3, add, 3, multiply, 3, add, 3, multiply, 3, add, 3, multiply, 3, add, also 3, multiply, 3, add, now it's a 4, times 1 is 4, 0 plus 4 is 4, multiply, 4, add, 4, multiply, 4, add, 3, multiply, 3, add, result 5. Okay, so f of 1 is equal to 5. All right. So that would be my answer, but this work needs to be there to get any kind of credit.
Wait, so like R, like the variable R stands for remainder in like everything, or?
It stands for root.
Okay.
Yeah, what we're looking for here is the remainder.
So if I see like f of 1,
1 goes on the outside.
right? How is that like the same as like plugging it into like where x would? Like if I plugged 1 in for all the x's, you would get the same result, right? But like, how does that work?
Well, that we're going to address that
Okay.
next class, yeah. Right now, we're just focused on the how. All right, I'll do another one. I'll do really numbers 1, 2, and 4 on page 11. They're really all asking the same thing. It's to do some synthetic division. It's just a question of how you choose to kind of approach it. Because in some cases, you might end up, or you might start off with a dividend, whatever that numerator is, that's factorable. So there are certain circumstances where you might choose to factor the original expression and simplify, right? But for now, we're just going to assume that every question is asking us to use synthetic division. So I'll do number 3. Number 3 is remainder theorem. So my powers, 4, 3, 2, 1, and 0. Again, not the powers that are there, the powers that should be there. All right, because each one has a coefficient associated with it. In this case, coincidentally 4, then 10. There's no power of 2, so 0, 19, and 5. Whatever is within your f of expression, that's my r. So I'm running through my synthetic division process, carry down the 4, multiply by -3, I get -12. Sorry. 10 plus -2 is -12 is -2. Times -3 is 6. 6 times -3 is -18. Add them together, you get a 1. So we're getting those sums along the way, and we end up with a 2 as a result here. So the remainder theorem tells me that f of -3 is equal to 2. All right, so carry down the coefficient, multiply, add, multiply, add, multiply, add, until you run out of room, and in that context, whatever that remainder is your answer. In number 4, this is, probably don't need to write this, but I'll write it anyway. This is the same as 2x to the 4th minus 1 divided by x minus 4. So it's the same question, just it's framed a little bit differently. Right here, my powers are 4, 3, 2, 1, 0. Again, skip that if you're fine. You don't need to write it. You do need the coefficients. The coefficients are 2, 0, 0, 0, and -1. Four goes on the outside, right? Because it's x minus r. So the r value had to be positive. Most people, it's just flip the sign of whatever's in the parentheses, right? So negative becomes positive.
If it was +4, it would be negative.
Yep. So I'm going to pull down the 2. Multiply 2 times 4 is 8. Add, get a result of 8. Times 4 is 32. Add, 0 plus 32 is 32. 32 times 4 is going to be 128? Yeah. So plus 128. 128 times 4 is 512. 256, 512, just doubling twice, which gets me 511. That's my remainder. We start off in my quotient with a power that is 1 less than whatever you started with. Started with a power of 4, so now it's a power of 3. Power of 2, power of 1, and then power of 0 just goes away. All right, pop in some plus signs. And I'll have my quotient, which is 2x to the 3rd plus 8x to the 2nd plus 32x plus 128 plus whatever my remainder is divided by my divisor of x minus 4. And that would be my quotient. Right? We'll get into the proper notation because we're just learning the skill right now, but we'll get into, so is this, what kind of function is this? Polynomial function, rational function, what's the domain, what's the range, and all that stuff. We'll cross that bridge in due time, but for now, this is